Okay, if we're going to calculate the pH of 0.1 molar hydrofluoric acid, number one, do you guys recognize that's a weak acid? How do you know it's a weak acid? It's not on the list, okay? Can you take HF and write how it would ionize in solution? What does that reaction look like? HF in equilibrium with what? Do you understand what I'm asking you? Yes. HF in equilibrium with hydrogen ions and fluoride ions. And all this stuff is aqueous. To show you how to calculate the pH for this, we're going to do an ice table. I can hear your enthusiasm. How come we got to do an ice table? When we did nitric acid, or hydrochloric acid, or hydrobromic acid, or perchloric, it was completely ionized, wasn't it? But this is a weak acid. It's not completely ionized. So the 0.1 molar HF, y'all, that is our initial concentration of HF, 0.10 molar. How much H and F do we start with? 0. How much of the 0.1 molar is going to ionize? We don't know how much. We just know X amount is going to ionize. So if X amount of HF ionizes, can you fill in the rest of that C line? Yes, isn't it going to be X and X over here? How do I know it's X all the way across and not like a 2X or something? Because the coefficients are 1 and 1 and 1. So it's just X all the way across. And so now I know that at equilibrium, I will have 0.10 minus X, X, and X. And so if I take these numbers from my equilibrium line and I plug them into a Ka, products over reactants raise the power of the coefficients, then I know that the Ka is going to be equal to the concentration of the hydrogen, which is X, times the concentration of the fluoride, which is X. Hang on, I'm going to break it down. Divided by the equilibrium concentration of HF. So in other words, it's going to be equal to X times X divided by 0.10 minus X. So isn't that all saying X squared divided by 0.10 minus X? Now I know that for this problem I'm working, the Ka is going to be equal to X squared divided by 0.10 minus X. Do you see that if I can solve for what X is, then I know what the concentration of the hydrogen ion is. And if I know that, I can figure out what the pH is, because pH is negative log of the hydrogen ion. Right? If I know a Ka for hydrofluoric acid, I can solve for X. So in your book, on page 687, there's a table of Ka values.
7.1 times 10
Okay. If you know the acid that you're dealing with, you can look up the Ka, always. But you got to know the acid so you can look up the Ka. Since this is hydrofluoric acid, I can look at that table and I know that the Ka value is 7.1 times 10 to the minus 4. And that's going to be equal to X squared divided by 0.10 minus X. Now hang on before you get to working it. Because some of y'all see we've got an X and we've got an X squared. And that's going to carry us through to the quadratic equation. You can't square root this one because 0.10 minus X, how do you take the square root of that? Right? We're going to do something even worse. We're going to pretend that X is going to be really small. And so it's so small that 0.10 minus X would probably give us something like 0.099997. Okay? In other words, y'all, let's assume that X is so small that it's not gonna matter. So we're gonna just take it out of the equation. So we're making an assumption. And that's okay for now. So assume X is so small that we take it out of the denominator. And now solve for X. I like to write it in scientific notation. It doesn't matter. What is X equal to? Yes. X, I see over here, is if I know what X is, I know what the concentration of the hydrogen ion is. From that original ice table. The problem said calculate the pH. How do I calculate a pH? pH is negative log of H. So for this one, isn't the pH going to be the negative log of whatever I get for X? Yeah, I got 2.07.
So wait,
Calculate the pH of 0.50 molar nitrous acid. See if you can set up the ice table. Okay, well, still feel like I shouldn't watch. Any questions on that? Yeah, this is where we end up with every time. Ka is equal to X squared divided by initial concentration. Orlando?
Basically, if it's not as strong as we get.
Yes, that's your only two choices. If it's not strong, then you've got to use this to solve it.
We're only going to use the ice table on weak acids.
And weak bases.
Okay, not the alternative strong acids or strong bases.
Right, you do not, I set up a quote-unquote ice table for a strong, but what y'all found is there's none of the initial stuff left, so you don't have to do it. So really the ice tables, they're in your what you're just seeing what they're gonna give you without having to set them up every time.
so that's just formula, like,
One more here and see if y'all can do it without the ice table. Let's calculate the pH of 0.25 molar acetic acid. Y'all do that one. How about it? You okay on that? Any questions?